Hello, and welcome to this Global Forum for Innovations in Agriculture GFIA presentation. My name is Dil Vashi from CO2 GRO. I'm the Corporate Development Manager, and today I'm going to talk to you about our technology called CO2 Delivery Solutions. So CO2 GRO is a Canadian company that's dedicated to enhancing plant growth and productivity sustainably, while helping to reduce our partners' ecological footprint by providing our patented CO2 Delivery Solutions technology. As I said, we're a Canadian company, but we have global partners and global customers, including in North America, South and Central America, Europe, Asia, Southern Africa, as well as the Middle East. Our partner in the GCC region is Gulf CRYO, which is the Middle East's largest industrial gas supplier. For more information, if you'd like to contact us later, Eli Adami, who is based in Dubai, is the Director of R&D, Innovations and Business Development, and his email is in the slide. So CO2 is often the common limiting factor in protected agriculture. We're able to control light, whether it's through natural sunlight or LED lighting, water, temperature, nutrients, but often CO2 is a limiting factor, especially in warmer climate conditions, like in the Middle East or even in Canada in the summertime. When it gets very hot, you have to vent, and venting typically means losing CO2 in the air. So that's what's difficult to control, and thereby minimizing plant production. The benefits of CO2 enrichment, if we are able to provide more CO2 to plants, is to accelerate photosynthesis. Of course, plants take in CO2 as part of photosynthesis and give off oxygen. But providing more CO2 for plants with better lighting and so on as well can increase in higher photosynthesis, faster plant growth, and increased plant production. So more pepper fruits, more tomato fruits, for example, more biomass, or more flower production if flowers are what you're producing. And we typically see about a 30% increase in yield by increasing the amount of CO2 that we can provide to plants, which means more production, more revenue, and more profits. Now, traditionally, growers who are in a seal structure typically are able to increase the CO2 levels in the air, sometimes up to 1,500 parts per million from their ambient conditions, which is usually 400 parts per million. And they do this by pumping in more CO2 gas into the grow room. Now, in a seal structure, that's additional CO2 gas can typically stay contained. What these blue dots represent is all of the CO2 that's required to fill a room, with the red dots representing the CO2 that's available to the plants at the plant level. However, as in the Middle East or Canada during the summertime, greenhouses have to vent to let some of the hot air escape in order to keep the temperatures in the greenhouse manageable. Of course, when you open the vents, you're losing CO2 as you're losing that hot air as well. So while you're pumping more CO2 into the grow room, most of that CO2 is escaping through your venting, meaning less CO2 in the grow room, usually levels of ambient conditions, even sometimes 400 up to maybe 600 ppm, which is less than optimal CO2. Most growers want to get anywhere from 800 to 1500 ppm. But when you're venting, it's very difficult to get up to those levels, which means less CO2 available for the plants and suboptimal growth conditions. So how do we do this? How do we provide more CO2 to plants in an environment where you're venting? Or if you're in a protected agriculture setting where you're continuously venting? That's where our technology comes in, CO2 Delivery Solutions. We provide CO2 to plants in a slightly different way, in two phases. Phase one, we take CO2 gas. We're agnostic to where it comes from. It could be typically your bulk tanks or liquid CO2 tanks. And we dissolve it and saturate it into water using our technology. What we do is we create a concentrated CO2 solution. We then take that concentrated CO2 solution and mist it onto plants to create a microfilm on the leaf surface. And by doing so, we're able to provide more CO2 to plants. As you can see by the red dots depicted here, we're providing more CO2 to plants, even though you're venting, so that you can enhance your photosynthetic activity and increase your growth. The key or the magic in our technology is actually in creating that microfilm when we mist. So we take that CO2 solution, that concentrated CO2 solution, and we mist it onto the leaf surface. And we create a microfilm. So if you can imagine a fogger that is misting onto the leaves, creating a film or a coating of the solution onto the leaf surface, what that does is it isolates the leaf from the atmosphere, and the CO2 that's in that solution then diffuses into the leaf from the entire leaf surface, from the top of the leaf. It has nothing to do with the stomata, which is where CO2 typically enters the plant through the air. We bypass the stomata, which is on the underside of the leaf. We focus on the top of the leaf surface. Now, because the CO2 is in solution, it's not exposed to the air, we don't lose the CO2 through venting. CO2 does not escape the grow area, and we're able to then provide additional CO2 to the plants year-round. So whether you're venting in the hot time, we can still provide that additional CO2 so that you can get additional growth. Because of this, we're able to convert CO2 from a limiting factor previously to now a strength. If anything, CO2 now becomes the one factor that we can continuously and consistently provide in optimal doses, along with, of course, your lighting and water and other regimens in order to optimize your growth. And we're a truly green solution. So we reduce the CO2 waste in the atmosphere. Of course, we're not pumping CO2 gas into the air. We're keeping it into the solution and directing it onto the plants. So you're not losing CO2 to the atmosphere. We have improved air quality for workers. There's no need to increase the CO2 levels in the air to 1,500 parts per million, which is 3-4 times as much as humans normally would breathe. We reduce pesticide and herbicide use, and I'll talk about that a little bit later. It's safe for plants, people, and animals to ingest. So if you happen to drink some of that CO2 solution, it's perfectly safe for you to drink. Less CO2 use means a lower carbon footprint. More yield means less resources wasted. We also have a very low operating cost. So as suggested earlier, we don't need to fill the entire room, the entire volume of the room with CO2 gas in the air. We're putting it into the solution, directing it onto the plants. So we're going from large bulk tanks to smaller cylinders and micro tanks. Typically, on average, we'll save about 90% less CO2 gas than you would if you're enriching the atmosphere with CO2, but still getting the same growth benefits. We have low energy consumption. We're just using pumps basically to move water around periodically. So what this results in is 30% more production and yield and revenue, a lower operating cost. For some growers, it could mean up to doubling of their gross profit margin, which is huge. Because our CO2 does not escape the solution, escape into the atmosphere, we can provide our technology to pretty much any type of protected grow, whether it's high tunnels, which typically have ends that are open, so there's no way you can gas in because it's going to continuously escape. Same with net houses and shade houses. Our technology works for either one. So long as we have some sort of protected structure where we can attach the pipes and the foggers onto, we can help with high tunnel grows, net house, shade house, some vertical farming, hoop house, greenhouses, any type of protected grow. Some data behind our technology. We first did a bench scale study on peppers where we took our CO2 solution and misted it onto peppers versus another group where we gas CO2 in a tent, maintaining a level of 1200 ppm throughout the growth cycle, and another group where it was just ambient CO2. And as expected, we saw a 20% increase in fruit production versus ambient conditions and 10% faster growth versus ambient conditions, which is similar to what you'd get by gassing. But unfortunately, as I explained earlier, not everybody can gas and maintain 1200 ppm throughout the year because of venting, or if they're high tunnel or net house, shade house, they're continuously venting and they cannot increase the CO2 levels in the air, but they can now do that, provide more CO2 to their plants using our technology and get the same benefits while using less CO2 and less costs as well. We then replicated this this study on a commercial scale, where we took a 1 hectare greenhouse in El Salvador with a customer, where half of the hectare we misted with our CO2 solution, half of the hectare was just ambient conditions. Of course, in El Salvador, it's always hot. They have open venting continuously, and they saw, as we'd expect, replicating the bench results with 20% more improvement even at the commercial scale. So it's totally scalable and proven at small scale as well as large scale. And we're happy to say that this particular customer, Hydro Export, actually bought our technology for 1 hectare greenhouse. They have 36 hectares of greenhouses, and their plan is over time to add more and more greenhouses over the years as they increase their profitability of their operation. We've also done bench scale studies on orchids, where we took CO2 solution and misted some orchid plants versus ambient CO2, and we saw that the flowering time went from 9 months to 6 months, therefore an increase of 30% faster growth. And bringing products to market 30% faster is a big deal, especially for orchid growers where the plant is very slow in maturing. Similar study on kale, where we took a containerized growth system. Again, our CO2 solution misted versus ambient conditions, and we saw a 37% increase in biomass. Again, consistent with what you would expect with increasing CO2 to plants versus ambient conditions, 20-30% more growth. Now, we're not spraying the plants or wetting the plants or drenching the plants. Our goal is just to create that microfilm, right? And so we're misting for only a few seconds at a time, typically 2 to 3 times an hour during the light cycle. And the reason we only need to mist for a few seconds is to create that microfilm. What you would see visually to the naked eye is just tiny droplets on the leaf surface, which typically dry off in less than 5 minutes. Now, one of the concerns that growers have is, well, what happens if I miss my plants? I'm going to be, promoting mildew and mold and all these types of pathogens. That's actually something which is not a concern with our technology, and our technology actually helps to suppress these types of pathogens. Why? It's because of the pH fluctuation. So the CO2 solution, when we create it, usually has a pH that's a couple of points less than your normal water. So if your normal water is 7, the CO2 in solution causes the pH to drop down to around 5. When we mist onto the plant surface for a few seconds, you create that microfilm. The pH on the leaf surface, which is the pH of the microfilm, drops to 5. That CO2 that's in the solution then diffuses into the leaf usually in around 30 seconds. And when that happens, there's no more CO2 in the solution, the pH on that surface goes back up to 7. So this happens every 20, 30 minutes, for 12, 15 hours a day. You're creating a fluctuation of drop in pH back to normal, drop in pH back to normal, and so on. That fluctuation, pathogens like mildews and mold and bacteria don't like. They want a nice, even, comfortable environment. We're basically making it very uncomfortable for them, and so it suppresses their spread. CO2 gassing, even at 1500 ppm, doesn't have this effect. It doesn't affect the pH on the leaf surface. And so this is a phenomena and a benefit that's unique to the way we deliver CO2 to plants. So you don't have to worry about the droplets on the leaf. We suppress the spread of these pathogens by 99%. As you can see here, in paddles that were infected with E. coli but misted with our CO2 solution, you saw practically no spread of E. coli versus E. coli paddles that were infected with E. coli and placed in CO2 gassing at 1200 ppm or ambient conditions. The E. coli spread like wildfire. You can see all the red dots everywhere. We try and achieve as much uniform misting as possible, even in big greenhouses, whether you're growing peppers or massive tomato vines like this. You can see the person there is about 6 foot tall, but the vines are almost 10, 12 feet tall. And we achieve this simply by putting our fogging lines in between the rows, placing the foggers to point towards the vines, and letting gravity do the work. So we run the misting for usually 20 or 30 seconds, for example, in this massive tomato vine, and the droplets basically fall down and coat the entire top to bottom of these taller crops. Or even if you have Shorter crops like strawberries, it's not a problem. We can put them, as you see in these pictures, basically in the rows as well. You're creating that fog, falls onto the leaf surface, creating that microfilm, suppressing the pathogens, and providing these strawberry crops with more CO2, even if these greenhouses are venting. And this is just an example at a lettuce greenhouse as well. Again, nozzles on top, you're spraying the top of the lettuce canopy, if you will. Many of our customers have the option to try before they buy. If you have a 10 hectare or 100 hectare facility, we don't expect you to say, great, let's roll it out from day one into all 10 or 100 hectares. We understand that at this stage of our technology development, people want to try it out. And so, we have no problem putting in what we call feasibility systems, where you can try it out on 5 rows in your greenhouse versus 5 rows that are control, and see the results. Once you see the results and you're happy with them, the business case is proven, the increase in yield, the costs, the extra profit, and all that is proven on a 5-row basis. It's just a question of scaling it up and rolling it out into your entire facility over time. And we have many ways to do that. The point is, we can start small and we can scale up pretty much infinitely to whatever your facility's needs are. And this is just an example of the infusion system for feasibility. You can see it doesn't take up much space. So if we're doing a 5-row trial, we're not going to take up a big space in your facility. It basically is a skid mounted size. This is a 50-gallon water tank within which the CO2 infuser fits, a CO2 cylinder, the misting pump, which sends the CO2 solution to the fogging lines, and it's done by control timers. So very low cost for a feasibility, and very convenient, as it doesn't require a lot of space. And once it's set up, it's basically all controlled by timers. So there's practically no labor involved in terms of operating the system. We sell the technology on a commercial basis based on the cultivation area. So, whether you're doing 5 rows of space or 1 hectare or 100 hectares, we price by the area that we're applying the technology to. We sell it as a capitalized cost, so it's not a long-term subscription model or anything like that. However, we do have flexible payment options. So a customer can buy something with 1 payment up front, or they can spread payments out over a number of years to basically bake in the purchase of the system from their increased profits and their cash flows. And that includes the CO2 infusion system, the technology site license for whatever area that you're purchasing for, misting system if required. Some customers already have existing systems which work for us. We'll have to see what specification they have, and if it works for us, great. If not, no problem. We can put in lines that do the trick, and of course, maintenance and support is always included. Other members of our team here in North America are Dr. Matt Julius, who's our Chief Science Officer. He's based in St. Cloud State University in Minnesota, where a lot of our R&D work is done. Our Chief Executive Officer is John Archibald, who's a professional engineer, and he works very closely with our clients to help with the design of the system and to ensure that everything is set up properly. And one of our board of director members is Dr. Gord Surgener, who's a retired professor from University of Guelph, which is one of the renowned agriculture universities in Canada, as well as him being on a number of agriculture boards in Ontario and Canada. And that's it. Unfortunately, we couldn't meet everyone in person, but hopefully next year we can do that. And in the meantime, feel free to visit our website, co2delivery.ca, for more information and videos, or send me an email, til.vashi@co2gro.ca. Look forward to hearing from everybody, and at least in the meantime, meeting you all virtually, and hopefully meeting you all in person soon enough. Take care.